Hello, everyone. My name is Tom Dawson. I'm a senior director with i3, and I'm here today to talk to you a little bit about empowering advancements in national law enforcement data fusion using Elasticsearch and some other tools. So why you should listen today is that criminal organizations out there and have basically they've adapted to the pandemic's challenges, and they're, as usual, a step ahead of us in many ways. So for us to catch up and in some cases to stay ahead, our National Law Enforcement Data Analytics Portal will allow law enforcement and intelligence analysts to search across millions of records to provide agents with the ability to visualize patterns and relationships and really pinpoint law enforcement efforts. So during this talk, you'll learn how Elasticsearch and Kibana improved the search performance and helped agents fuse multi-source intelligence to make decisions faster and with greater precision. So today we'll show you an example of Symantec Salsa's enriched data in an upgraded search engine known as Elasticsearch. So why Elasticsearch? Really, it's because of the fuzzy searching and exact searching capabilities of Elasticsearch. It allows us to go across structured, semi-structured, and unstructured data very rapidly. It's secure, it's massively scalable, and it's available on Azure as both a service and in FedRAMP certified containers. Another reason we chose Elasticsearch is just that they're investing a tremendous amount into this arena, and the technology is basically out there in front of everyone else. So it's almost a no-brainer at this point. We stood up Elastic running in Azure in this case, and we ingested an enriched open source data set. And today I'm going to highlight 3 innovative use cases for you. The first one is a relational graph network, or really this network view that you see here. Basically that we're going to show you that and how it's brought in from Kibana. We're going to show you also a person-focused orchestrated search in Kibana that we're calling a dossier view, and how we tailored that view to our analysts' needs. And lastly, the third innovation is we want to show you an organization-focused orchestrated search within Kibana. So really the questions asked of us all the time, how do you find reliable connections in the data? And the answer is Symantec's data enrichment service. So before we can reliably view the networks and the bad guys, we really need to enrich the data at rest. And this is done with Symantec's Salsa. It's a proven, engineered, quantifiable process and a service that runs in the cloud, and it highlights most of the relationships sitting in our entire data set while at rest. I first met the guys at Symantec right after 9/11 when we were working together on a national counterterrorism center problem. And since that time, we've worked together on a number of problems. And basically, they have a rich semantic data model that's been specifically designed for identity intelligence applications and refined with about 20 years of Intel community, DoD, as well as DARPA experience. And in a nutshell, that process is composed of these steps, and I'll just walk you through those briefly. The first step is natural language processing, which renders things like PDFs and fuzzy texts and different sorts of textual information machine readable. And then the next step is geotagging, which puts a latitude and longitude coordinate on things as random as street corner names, addresses, and so forth. Then we go down to entity resolution, and really what that means is pulling out and making sure that the computer understands the types of entities that are of interest to the analyst. And an entity is not just a person; it can be a weapon, it can be a vehicle, it can be an organization, right? So the entities are carefully resolved to the affinity of the using organization. And I'll go into that a little bit more about how that's done later. And then those entities are disambiguated. And what that means is we want to separate John Frederick Smith from John Smith. And we want to make sure that we are carefully understanding both similarities between different people and organizations, and also we're not overly overly coalescing those entities. So then we go into relationship scoring. And there's a very complex set of processes that are run looking for different types of relationships. One of these relationships might be that I call another person, so that indicates some relationship. If I call them a lot, that indicates a better relationship. We also have relationships that come from co-appearance within documents. Those can be sort of less stable or less valuable relationships, but they can be meaningful at times. Then you might have co-location relationships where two individuals met in the same place. And even though they never call each other and they're never in the same document, the fact that they've met 2 or 3 times in the same latitude and longitude can be an incredibly important relationship to discover in terms of within a criminal organization. And so really, once all of that is done, then we're ready to index this enriched data within the Elastic construct. And then that's all served up to the analysts in a way that they can sort of vet and make sure that we've made good enrichments and good computational judgments. And that allows us to basically have a data lake that's fully refined and trustworthy, and not just an ocean of data that's random. So a word about our data. Normally I go into a lot about this scenario, but I'm not going to do that today. I just want to stress that the bad guys we've identified here come direct from a website that's run by the Treasury. It's actually a list of specially designated nationals, and those were designated by the director of the Office of Foreign Assets and Control. So you don't need to worry about their identity being protected. So right into the first innovation. Our first innovation is essentially a Kibana graph or network view of associations and connections, including influencers. The influencers tend to be more in the middle of the network. And in this view, you can see that we have a drill down capability. So I'm just running this off of canned screenshots, so please forgive that. It's not a live demo, but if I was running a live demo, I would click on this link and that would pop up this box, and it would explain that the link is basically solidified and underscored by 5 documents that have these 2 terms in them, right? So the 2 nodes are connected and really established with 5 different documents. All right, everyone. So here we have a simple example of entity resolution within a document. And I'm going to show you those entities that were highlighted. You can see that US Treasury and other organizations like Spectrum Investment Group, those are highlighted in yellow. Individuals are highlighted in green. And then this one, Adam Tabaha, is actually highlighted in red because he's an individual of interest. So that's that ability to highlight and extract key terms from the text. That's what we mean by entity resolution. But before we can do that in a way that makes sense, we really need to understand that entity resolution happens based on a reference data model. And this is a very simple example of a reference data model. It just shows you that people have the attributes like date of birth, place of birth, gender, occupation, social security number. They also have, and a physical address has attributes such as city name, country, postcode, right? And so we quickly understand that the entities are made up of key details, and this data model really is where semantics shines, because if your data model is not detailed enough, then you're not able to pull out the entities that are of interest to your analysts. And if it's too detailed, then you end up with just a mess, and everything is highlighted and everything's interesting, and there's no ability to really discern the topics of interest. So that just gives you a deeper level understanding of what we mean in the terminology I've been using. So now I want to tell you about our second innovation, and this is really this dossier view that we built in Elastic's Kibana. The dossier view, you could also call it a person-focused orchestrated search. And really, I like to think of this as almost like when you go to a search engine and you look for a restaurant, you see a combination of things. You see pictures of the restaurant, you see the menu, you see ratings, right? You see business hours, you see whether or not they take reservations. Is it good for kids? So that sort of orchestrated search is what we've tried to do for the analysts that we're trying to serve. So you can see that we've got a picture of Adam Tabaha. We've got his names, his fused names, right? We've got his gender, his date of birth, location, national ID, and we've got a nice paragraph, descriptive paragraph written about him by an analyst. We also have his family members. We have his professional associations. We have different people that are possibly the same person as Adam Hussein Tabaha. And you can see this is a really neat feature right here. We have this score of 0.95, right? That means that Adam Tabaha, there's a very high likelihood that that's the same person as Adam Hussein Tabaha, right? And we can let the analysts review different folks that might or might not be Adam Hussein Tabaha based on a number of factors. And so in time, you're actually able to see through certain types of cloaks and screens with these functionalities. You also have associated persons, right? And so in the future, we would like to also go ahead and take Adam Hussein Tabaha's, network view, his graph view, and we'd like to put that on the same screen. But that's something we haven't completed yet. Our third innovation that I want to talk to you about is just an association view, and it's really an organization-focused orchestrated search. And here, instead of just looking at the person, we have a number of different organizations. In this case, we typed in INMA, and we can see there's the Al-INMA group, there's the Al-INMA for entertainment and leisure products, right? Or projects, and there's just a number of different organizations that have the term INMA in them. And then we have that same ability to really differentiate between possibly same as organizations, right? So the Al-INMA group for tourism works and the Al-INMA group, they have a similarity score of 0.94. So those are likely to be almost essentially the same organization. And then you have down here, you have organization associated persons. So we can see that Adam Hussein Tabaha is the owner in this, and he's also an officer of the company. And we might be able to see and, extract different other officers from this view. And then you would have associated organizations that appear to be doing business with or have links to this organization. And again, all of this is just built and co-located in order to help our analysts do a better job. So the way you do this for your particular use case and customers would be possibly different. And that's really all I have to go over today. A little bit about i3. These are some of our vehicles that we have. We are also putting in for CIO SP4, and you can see that we have a deep bench of experience, wonderful host of advanced degrees, and our folks have, almost all of our folks have clearances, and we have very high customer satisfaction. And we've gone to a number of federal clients, and we are an 8A minority-owned business. And just recently, we won a nice bit of work with the Department of Interior in addition to these folks. So this is me and my contact information, and this is my boss, Nick Nguyen. And look forward to hearing from you, and thank you very much for your attention and your time today.